On today's episode, why do pickup trucks use 19th century structures? Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. This is a Supermarine Spitfire, an iconic high-performance World War II airplane. And this is a Hawker Hurricane, a not quite so iconic contemporary of the Spitfire, built to perform the same tasks and using the same engine. Now, the Spitfire was a significantly higher performance airplane, and a major reason why was its construction technique. It used a monocoque, meaning that the outer skin of the aircraft was a stressed structural member. On the Hurricane, the skin was simply a covering over a tubular frame, durable and easy to repair, but notably heavier. Now, lightweight with strength was the secret to the Spitfire's high performance, but the auto industry in Europe recognized this advantage as early as the 1930s, with Citroën's revolutionary Traction Avant. Now, in America, progress moved more slowly, but a key turning point was 1960, when Chrysler Corporation's large cars and a new generation of compact cars from Ford and General Motors switched from the Hurricane concept of a body attached to a frame to unitized construction, essentially a monocoque. Now, in auto production, the concept was to use stamped, lightweight sheet steel and spot weld it with cleverly designed channels and box sections to make the body stiff and strong enough to mount the drivetrain, steering, and suspension to it directly. The older technique, body on frame, went back to the horse and buggy days, and today it's still seen on most pickup trucks and full-size SUVs. It's heavier, more prone to squeaks and rattles, and produces a vehicle with inferior handling to unibody vehicles. So why hasn't anyone tried unit construction for light trucks? Well, they have, with a notable example being the Honda Ridgeline. Now, compared to body-on-frame light trucks, it is not a sales success. But why not? The historical reason for the persistence of body-on-frame in pickup trucks is the need to adapt different cab and chassis configurations onto a common set of frames differing only by overall length. Regular cab, extended cab, crew cab, and multiple box lengths were once common, and it's certainly cheaper to build them all with common body tooling. But in an age when fuel efficiency demands lightweight, and Ford has gone so far as to develop special aluminum alloys to lighten the body, why bolt it onto a heavy frame? Now, in the time-honored tradition of engineering personnel everywhere, I blame marketing. For decades, old-fashioned technology and the perception of high strength in body-on-frame construction has been used by industry marketers to sell their product. In the light truck market, manufacturers wear obsolescence like a badge of honor. I once owned a Ford pickup which was advertised as featuring massive twin I-beam construction. Now, it drove like a Conestoga wagon and used the same 19th century kingpin technology in the front spindles, and when I traded it for a late 90s F-150, the difference was night and day. The later truck was tighter, quieter, rode better, and had a higher payload and towing capacity while burning less fuel than my old 85. But it still used a heavy steel frame. Now, Honda has tried and frankly failed to break that mold. Now, how about at Ford and GM, and Ram too? You're going to have to electrify these vehicles soon. Now, how about bringing them into the 21st century in the chassis too? Well, that's it for today's episode of End of the Line, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.